We are told the subatomic world operates differently from the classical laws we experience in our everyday life. The world of atoms can seem strange and counterintuitive, governed by probability. Still, I can't help but see parallels when I try to grasp their world through the lens of my own. I find patterns that feel familiar to make sense of the discrete world. What I see are electrons arranged hierarchically, some shunned to the outer confines of the atom, away from the cozy attraction to the nucleus. These electrons which are present in the atom's outermost shells also desire companion electrons to form bonding partners. In the words of G. N. Lewis, an atom can find stability when its outer shell can accommodate 8 electrons. Carbon, nitrogen, oxygen, and halogens take the rule of 8 very seriously. These atoms attempt to form covalent bonds, allowing each combining atom to retain 8 electrons by sharing. Chemistry determines the number of bonds these atoms can form, known as their valencies. Therefore, carbon can form 4 bonds, nitrogen 3, oxygen 2, and halogens 1 bond. However, there are valence electrons in the outermost shell that rebel. They don't take part in any bond-forming interactions, and these recluses get labeled as the lone pair. Nitrogen can have 1, oxygen 2, and halogens 3 lone pairs, which are denoted as dots over the atom symbol. But recluse doesn't mean timid. They are controlling, bending a molecule's shape by increasing repulsive interactions. Also reactive when necessary. They are known to donate their electron density to atoms deficient in electrons belonging to a group known as the electrophiles. By doing so, they form a new covalent bond with the electrophiles, but they do it in their own terms. In the language of chemistry, the lone pairs are an atom's valential electrons that took part in hybridization, but evaded the covalent bond formation with other atoms. So the atom now has 2 sets of outer electrons, bonding electrons and non-bonding electrons, also referred to as the lone pair. You can read all about the lone pair, its exceptions, and physical and chemical properties in the chapter Fundamentals of Organic Reactions by signing up for the course on Organic Chemistry Fundamentals at Curly Arrows. Also below is a link to the quiz on lone pair. Happy learning from Curly Arrows, simplifying concepts one lesson at a time.